We will now have a look at some set operations. The idea with an operator is that it will take two objects, in this case sets, perform an operation on them to produce another set. The two sets that we are operating on are called the operands of the operator. So in the first example we will look at intersection. Intersection is a set operation taking two sets and producing a third set. So as a definition we can see the following. The intersection of set A and set B, written as A intersection B, is the set that contains elements which are common to both A and B. So we write this as A, and then the intersection symbol, an upside down U, B. And in set builder notation it's written as follows. So A intersection B equals the set of all X, such that X is an element of A and X is an element of B. So with set intersection, what we're trying to do is to determine which elements are common to both of the sets we're operating on. We extract those common elements to produce the resulting set. Another set operation that we will use is the union operation. In this case, again, we take two sets as operands and we perform an operation on them, the operation of union. Now, if we look at the definition, we see that the union of set A and set B, written as A union B, is a set that contains elements which are in A or B or both. So the idea of the union is we are looking at all of the elements in the first set, all of the elements in the second set, and the resultant set of the union operation will contain all of those elements. So whether the element was initially in A or initially in B, or whether it was also a common element that was in both sets. So to write this in set builder notation, we would say A union B equals the set of all X, such that X is an element of A or X is an element of B. Let's take a look at some examples. Okay, let's take some examples of both the intersection of sets and the union of sets. So with that set intersection, we are trying to find common elements that are in two sets. So let's consider the set A. And let's say A contains the following elements: A, B, C, D, and E. And let's consider the set B. And B contains the elements 1, 3, A, D. So for the intersection of these two sets, we are trying to find the common elements, and that will then produce a new set. So let's call the new set C. And we're saying that C is going to be the result of the intersection of A and B. So C equals A intersection B. So exactly then, what is A intersection B? Well, let's just have a look and extract out the common elements. So let's go through each of the elements in A and see if it is also in B. So the first element in A is this lowercase a. And we check to see whether this lowercase a is also in B. So it's not the element 1, it's not the element 3, however it is the third element listed for the set B, so yes, it is common to both. So it will also be part of the intersection. Okay, so let's see if we can do the same process for all of the elements in A. With the element B, we can see that B is not an element of the set B, so it's not going to be part of the intersection. Likewise for the element C of A, C is not in B, so it cannot form part of the intersection. The element D in A is also in B, So this would also be an element of the intersection. And finally, the element E of A is also not in B, and therefore will not be part of the intersection. So we've exhausted all of the possibilities, and the resultant set of the intersection in this case will be the set with elements A and D. Okay, let's do another example of an intersection. Let's take this time the set X. And let's say X is the set with elements T and Y. And let's take the set Z with elements 1 and 2. And let's again see if we can form the intersection of these two sets. So let's look at X intersection Z. Well, if we go through the same process as we did last time, let's examine the elements of the set X. So the first element here is T. Is T an element of Z? The answer is no. So it will not be part of the intersection. And the second element in the set X is Y. Is Y an element of Z? The answer is no. So Y will also not be an element of the intersection. So we can see in this case that we don't have any common elements between the two sets. So in this case, the resultant set of the intersection will simply be the empty set or the null set. Let's have a look at some union operations that are formed between sets. So the idea with the union operator is that we will take two sets, and they are the operands of this operator, and the union operator will form a new set, and this new set that's formed will include all of the elements that are in either of the two sets that are the operands of the operator. So let's have a look at an example again. Let's consider the set A, and A will contain A, B, C, and D. Let's consider the set B, and B will contain the elements 1, 3, 4, and 5. Okay, so we want to create a new set. Let's call this new set C, which is the result of the union of the sets A and B. So C is going to be the same as A, the union operator, B. So to form the union, we essentially take all of the elements from set A and take all of the elements from set B. So let's list out the elements in set A. So we know that each of the elements in set A will be part of the union. So we've got A, B, C, D. And we know that each of the elements from the set B will also be a member of the union of the two sets. So we've also got in here 1, 3, 4, and 5. So the resultant set contains 8 elements. Okay, let's take another example then. This time we'll use the set X equals the set with elements 1 and 3, and we'll also take the set Y equals set with elements 3, 4, and 5. So what is the union of these two sets then? So we're trying to find X union Y. So again, we need to include all of the elements from the initial set X and the set Y. So let's start by listing the sets from the elements from the set X. So we've got here 1 and 3. And then we also need to include the elements from the set Y. The first element in the set Y is the number 3. Now, the number 3 was also an element of the set X, so we don't need to actually list it twice in the resultant union set. So even though 3 is an element of y, we've already included it because it was an element of x. So it's already represented in the result set. So we can move on to the next one, which is 4. And then finally we have the last element from the set y here, 5. So the resultant set in this case is the set with elements 1, 3, 4, and 5.